For fossil fuel resources, be able to discuss the use of coal and its consequences, the use of petroleum and its consequences, the use of natural gas and its consequences, and discuss the use of oil sands and liquefied coal and their consequences. And then describe the future prospects for fossil fuel use. What does the future hold for our fossil fuel resources? So, coal is a solid fuel that's formed primarily from the remains of trees, ferns, and other plant material that was preserved 280 to 360 million years ago. And coal has been the workhorse of fossil fuels in the United States and in many other parts of the world. It is abundant in many areas and often relatively easy to extract, handle, and process. We've seen that coal is the fuel most commonly used to make electricity in the United States, but there are three different types of coal. Here we're going to rank them from lesser to greater age, exposure to pressure, and energy content. They are ignite, bituminous, and anthracite. There's also subbituminous and just regular bituminous, and we'll explain the difference between those. A precursor for coal, which we call peat, is made up partly of like decomposed organic material, including moss. But the formation of coal takes hundreds of millions of years. It's represented the formation of different types of coal, starting from organic material like peat, increasing in time and pressure to produce successively denser coal with more carbon molecules and more potential energy per kilogram. So the largest coal reserves are found in the United States, Russia, China, and India. The countries that are currently producing the greatest amounts of coal, however, are China, US, India, and Australia. Because it's energy dense and plentiful, coal is used to generate electricity and industrial process like making steel. And in many parts of the world, coal reserves are relatively easy to exploit just by surface mining. The technological demands of surface mining are relatively small and the cost is pretty low. So once coal is extracted from the ground, it's relatively easy to handle and needs little refining before you can just burn it. It has been transported to power plants and factories by train or barge or truck, and so all these factors make coal a relatively easy fuel to use, regardless of what technology or development or infrastructure the country has. The disadvantages, though, is that coal is relatively inexpensive fossil fuel. It does have several disadvantages besides that. As we saw before, the environmental consequences of the tailings from surface mining are pretty significant. And as surface coal is used up and it becomes harder to find, surface mining becomes necessary. With subsurface mining, the technology demands and costs increase. And here goes the consequences for human health as well. Because coal contains a number of impurities, including sulfur, that are released into the atmosphere when the coal is burned. The sulfur content of coal typically ranges from 0.4 to 4%. Lignite and erythricite have relatively low sulfur contents, where the sulfur content of bituminous coal is often much more high. Trace metals like mercury, lead, and arsenic are also found in coal. So, combustion of coal results in the release of all these impurities, which leads to an increase in sulfur dioxide and other air pollutants like and particles into the atmosphere. And we'll see that these compounds are not released into the atmosphere and easily removed, and they also leave behind this resulting ash. So in order to reduce the chemical compounds released into the air, coal companies wash their coal in a variety of organic compounds. In some cases, these compounds have they've not been used or widely tested for if they're toxic or their effects on human health or ecosystems. In fact, in January of 2014, a chemical storage tank containing one such chemical, a cleaning compound, it leaked into West Virginia residents. Nearly immediately noticed a sweet odor in their water, and so over 300,000 residents were advised to not drink their water for a number of days. And unfortunately, chemical spills are not the only accidents related to coal combustion. The residual ash from the coal combustion is also a problem. But Coal comes in different forms, and here you can see in the figure that the coal formation process, it starts off as this peat raw material, and then over millions of years we increase in pressure, the increase in pressure, due to how far it is underneath layers of rock and sediment, it can actually form different types of coal. According to the U.S. Department of Energy, there are 1,450 coal mines in the U.S., and most of the coal burned in the U.S. is anywhere from 3 to 20% remaining ash. It leaves that much behind. So large deposits of ash are often stored near coal burning power plants. One such ash deposit, which is a mixture of ash and water, was kept in a holding pond at a power plant near Knoxville, Tennessee. And in December of 2008, the retaining wall that contained this ash gave way, and it spilled 4.1 billion liters. That's 1.1 billion gallons of ash all out. And so 3 houses were actually destroyed by this flow of like muddy ash, and that covered over 300 acres of land. The event was the largest of its kind in U.S. history, and it took 5 years and over $1 billion to clean up this bulk ash. Coal is a significant source of air pollution. Coal is 60 to 80% carbon. So when it's burned, most of that carbon is converted into carbon dioxide, CO2, and energy is released in that process. So coal produces far more CO2 per unit of energy released than either oil or natural gas. And its combustion is increasing atmospheric concentrations of CO2. So petroleum is cleaner than coal. Another widely used fossil fuel is petroleum. It is like this fluid mixture of hydrocarbons, water, some sulfur that occurs in these underground deposits. And while coal is ideal for stationary combustion applications and those in like power plants and industry, the fluid nature of petroleum products like oil and gasoline make them more suitable and more mobile combustion applications for vehicles. So petroleum is formed from the remains of these ocean-dwelling they're phytoplankton, they're microscopic little algae, and they died like 50 to 150 million years ago. The deposits of this phytoplankton are found in locations where porous sedimentary rock like sandstone are capped by non-porous rock. And so petroleum forms over millions of years and fills the pores of these rock. And geological evidence relates that the tectonic cycle that we discussed earlier may deform the rock layers so they form like this dome. And the petroleum is less dense than the rock, so over time it migrates upwards towards the highest point of this porous rock, where it's like trapped by the non-porous rock. But essentially, what's not always explained is like these phytoplankton, it's like little guys here. And it looks like a jellyfish, but it's really not. Okay, they're like little guys. They stay suspended, in the water column, and inside of their body, part of their suspension is this little tiny droplet of oil. Like you have oil in your body, they have it too. And the rest of this stuff is all photosynthesizing, components. And so when these guys, when they die, their bodies, sink to the bottom. And of course, the rest of this tissue is biological. But the oil part, the oil tends to accumulate under rock. And so, we form these deposits. Oh, here's a great photo. All right, so you can see the oil rig up here, which drills into this oil part. And so we have the non-porous, like rock, cap rock, which they'll call it, and the sandstone or more porous rock underneath. And so it becomes almost encapsulated, in this oil accumulation. So usually petroleum producers must drill wells into this deposit and extract the petroleum with pumps. So after extraction, the petroleum must be transported to a refinery by pipeline. if the well is on land, or by like a super tanker if the well is underwater. So petroleum contains natural gas, and as we can see from before, some of the gas separates out naturally. And if you've ever seen a burning flame in the photographs, like of the oil wells, where the gas is like on fire, it just continues to like make these like waves of little flames. That's what we call burn off. And so the natural gas, which is done under controlled conditions to prevent an explosion. So they're burning it off as they're extracting the oil. Anyway, let's talk a little bit more about these extracted fuels. I mean, as you can imagine, if we're doing this under the ocean or somewhere, when we're using petroleum, we do release carbon dioxide into the atmosphere, but also there can be leaks from this extraction process. Not to mention, if there's leaks and it's out in the middle of the ocean, runoff enters like these marine ways from where the extraction little pumps are. And then not only that, but we're talking about releasing things that are buried. So sulfur, mercury, lead, arsenic into the atmosphere when we burn it.